Okay, kudos to all the people that make all those professional looking YouTube videos, because this took me a long time just to be able to see this, and hopefully you can see it. But this is the work I've been doing. And I'm kind of going to go over this right here, which is the MOSFET circuit board, which turns on 12 volts and turns off because an Arduino can't do 12 volts. So basically you have the Arduino, and I'm representing that with the battery, which would be the input. It goes the ground, goes to the transformer. So you will see that you have a ground here that goes on the circuit board itself. That would be right here. And then the output of the Arduino goes through a 1,000 ohm resistor. This is because of backflow. You don't want it to, when it turns off, to have that electricity go back to the Arduino, so you put a resistor in there. And then you also put a 10,000 ohm resistor, because this will keep residual electricity, and you want to get rid of that, so it'll trickle out of here and go back to ground. And so then it goes to the gate. This is the MOSFET, and the gate is what turns it off and on through the Arduino. It's kind of like the switch. And then you have the drain, which goes to the negative side of the LED or the motor, which is kind of backwards. Usually with a relay you think about it going forward, a positive, but it actually turns it off and on by the negative. So that's your kind of your switch. And then you have the LED, and the negative side, or the negative side of any motor or whatever, would go to the drain, and it's controlled by the negative, which is what I just kind of said. And then you have the source, and that is the loop that turns it off, and then it comes back to the negative side of the transformer or energy that you have. And then the positive side is a positive bus. So on this you have the positive side right here, goes through, and all four of these LEDs, the lamps, are positive. This is positive here, and then they have an individual negative on each one of them that goes back, and then it goes into every one of these. So I have 4 LEDs, and I have 4 negative sides going in, and 1 positive that goes here, and you can see it's negative, positive for the transformer, and then positive that goes to the LEDs. So if you were to look at it this way, you would see that if I touch the negative side, the input, the light goes on. So the positive side goes through here, negative side goes here, and then your input, which would be the gate, is right here. You can see it works. Okay, so this is the work I've been doing for the last 2 days. Basically, I have that circuit board. I have 2 Arduinos, although I'm only using 1. Goes through here, goes to the GTN 750 rotary dual encoder, push button, and you can see that I'm using copper wire, bare copper wire. That's jewelry wire for all the negatives. Since it's not moving, it's not going to fly anywhere, you can just use it like this, and a little hot glue to keep it from moving around. You're not going to have problems with shorts. And then I have a little angle. This is just a $40 touch screen, and then this is a $60 touch screen that I got that'll emulate the G3X. The push buttons for and rotaries for the G3X are actually over here, because I couldn't put them in here, but you don't hardly ever use those anyway. I have my gear down, I have my gear bypass, I have my go around, Togo, and then I got my best glide button here. And then I have all my control switches right here, 2 rotaries that encoders that will control the intensity of the lamps. So they're going to have on and off switch by themselves, but I want to have a master controller so I can control the intensity of them. Pulse width, I'll use pulse width on that. And then the other one will be a pulse width on cabin. So I can use this again, use the 12 volts, and that way I can use car LEDs, and then I can control that just by this transformer. It's a 12 volt transformer that I connected to the barrel jack. That'll go into that, and then that'll drive the 12 volts. I have my master and my avionics. So that's pretty much it. I used this channel, worked out pretty good. I had to cut it and angle it and bend it and stuff, but it bends pretty easy, so it wasn't too hard. I think that pretty well covers it, and hopefully next time you'll see it, it will be in the simulator, and I'll be using MobiFlight to drive it and do the logic. One other thing is mounting this, all I did was the holes were already drilled. I had to widen them a little bit, but I just put these on, and then I used Velcro. I'm like, oh, these straps might work. And then that seems to hold it pretty good. If it doesn't, I'm probably going to be taking it out again, taking out the panel again, so I can always hot glue it to mount it. It's not that heavy, and so that should work.